check my recording is from the right microphone. Yep. Okay, so that's good. Okay, so this is your new homework assignment. It combines several things that we talk about when we talk about subroutines in this homework assignment. The file is a little bit different, so we'll go ahead and download it and take a look at the pseudocode. I'm not going to trace this program, obviously, but I will talk about, I will use a sample program to demonstrate a kind of quote-unquote new concept that you need to understand for this particular homework assignment. Okay, let's do it again. Okay, so this is the actual new homework assignment, and I'll just go ahead and zoom into the pseudocode first. Okay. Subroutine traverse is what you need to trace. Well, eventually you need to trace that one. There's also the main subroutine. The one part that we haven't done before, which is a new combination. Okay, it's a mixture of concepts that we already understand, and also a new concept that we have not seen together before. It has to do with A, which is a parameter passed by reference. Okay, so we talked about passing by reference prior to exam 2 already. So this is not a new concept. We have talked about that already. Any parameter that is passed by reference is an alias. In other words, it refers to other columns. In this case, A is a little bit special because the way I use A, or parameter A in this case, is I use it as an array. Okay, here you can see the bar A bar notation, and over here you can see the indexing operation with A. H is pretty simple. H is just passed by value, so it's not that special. And we have a local variable sum here. It does have recursion. Okay, so if you look at this line here, we do have a recursion, which is not really that different from the other types of recursion that we have seen in this class. Okay, so what are we going to do with this particular homework assignment? The difficult part has to do with what are we doing with this A here, and how do we pass an array by reference to a subroutine? Because when you look at main, main has a local variable A, which is an array of 7 elements, and I do the initialization here, and then on line 24 I use A, which is my local variable, to pass it to parameter A. So that really is the question. How do we do this, and how do we refer to parameter A inside the subroutine? So those are the things that's a combination that we haven't seen before. It's a combination of passing by reference and also the concept of using arrays in this class. So let's go ahead and start with a new program just for demonstration purposes. And I'll go ahead and define this subroutine here. It's the same kind of subroutine that I use for my morning class, so I'm going to make exactly the same mistake, but this time it is intentional to illustrate one point that is actually kind of important. Some people may run into this in cisp300. Okay, so here's a subroutine that I just called it sum. I use passing by reference to pass in an array A, and then I use by value, passing by value, a parameter I here. And then what I'll do is to say if I is less than bar A bar, then we'll do something. What we'll do is we'll return we'll return the value of A bracket I plus the invocation of sum, passing A to A, but passing I plus 1 to I. Like that. And if, and define sub. And as I said, this particular subroutine has a problem. So we'll go ahead and trace it until we encounter a problem. And then we'll kind of fix it and then trace it again, but only from that point onward. Define submain. We have a local variable. Let's call it B, so I just choose a different name this time. And local variable B is an array of, let's say, 3 integers, okay? And then we'll go ahead and initialize array B. B bracket 0 gets a value of 5. B bracket 1 gets a value of 3. And then, oops, I said B and then wrote A. b bracket 1 gets a value of 3, b bracket 2 gets a value of, let's say, 10. Okay. And then we'll go ahead and invoke the subroutine. Well, we'll go ahead and print the result of invoking sum, using a to specify a, 0 to specify I, and define sub, invoke main. So that's my entire pseudocode as an example. All right. Let me put in the line numbers. And the line numbers will get kind of interesting later on, but right now it's just fine. Okay, it's pretty normal. Okay. Can everybody see the similarity between this sample program and the homework assignment? Okay, the one thing that we haven't seen before is not the return statement itself. It is not passing by value. It is not passing by reference itself. It is the combination of passing by reference and the concept of an array. So this has pretty much the same kind of element from that perspective as the homework assignment. So we'll go ahead and trace it on this side. And not much is going to happen until we get to the subroutine invocation. We need one line or one column for comments because we do have one condition to evaluate on line 4. We have our usual line number. And as the precondition, there's nothing to say in this case because we do not have any global variables. Now, in this class, how do we know there are global variables or not? You look at the names that we refer to and you ask, okay, is every name accounted for as a local variable, as a by reference parameter, or as a by value parameter? If a name is accounted for by any one of those definitions, then it cannot be a global variable. If you look at subroutine sum, we have two names here. We have I and also A. A, I, we have A and then I. But both are accounted for as parameters. A is passed by reference, I is passed by value. So they're both accounted for, they cannot be global variables. When you look in main, we only have references to B. And B is a local variable. So that's why in both cases, all the names are accounted for as local variables or a parameter, either by value or by reference. And therefore, there are no global variables in this program. So there's nothing to say as a precondition. We can start on line 15, by the way. Line 15 is invoking main. If you look through the entire subroutine main, it does not use a return statement at all. So that's why we can use a return line number in this case. And the return line number is simply post, which is the line following line 15. But there's some extra stuff we have to do because main has a local variable that we call B. But B is not a single variable. In other words, it doesn't take up just one single column. Every time we refer to an array, it occupies multiple columns. And this is no exception, except we are allocating the columns on the fly. So we are allocating the columns, or the leftmost available columns in this case. And since I claim that B is an array of 3 integers, we're going to allocate 3 columns in this case. So B bracket 0, B bracket 1, and B bracket 2 will occupy columns D to F. Like so. Are there any questions at this point? How we allocate columns when an array is local, is a local variable? No questions? Okay, so it's kind of like an extension or a combination of concepts right here, because we talked about local variables are allocated on the fly per invocation, and here we have an array that is allocated on the fly on a per invocation basis. And just like any other local variables, when you have an array that is locally allocated, you also have to make sure that each column starts with an unknown value. So this concept also applies to an entire array when you have an entire array as a local variable. Are there any questions about these concepts? It's a combination, except it's not that tricky. The trickier part is on line 13. So now we can continue execution in the subroutine starting on line 10. Line 10 is pretty simple. In fact, line 10, 11, 12 are all pretty simple. B bracket 0 gets 5. B bracket 1 gets 3. And the B bracket 12 is getting 10. Okay, so we are just initializing values into the array. Line 13 is the one that is kind of tricky, because how are we going to pass an array by reference to a subroutine? But before we even try to answer the question, we have to look at line 13 and say, well, I know that we have to invoke the subroutine sum, but when subroutine sum is done for this particular invocation, we still have some additional things to do on line 13. We cannot just continue onto line 14 right away. So as a result, instead of using return line number, we have to use return info, because we are returning back onto line 13 to finish some unfinished business on line 13. The way we write or we construct this return info column is the same way as before. We write down line 13, which means when this particular invocation of sum is done, we have to get back onto line 13 and finish some operation on line 13, which involves the printing part. The invocation of sum is replaced by a single question mark because it is a placeholder for the return value of sum in this case. So that's how we set up the return info column. This part is not new. This is pretty much the same way we set up return info as discussed before exam 2. We have two parameters in this case to set up. We have parameter A and parameter I. I'm just going to allocate one column for parameter A and one column for parameter I. And you can see that even though A is an array, we only use one column to represent it because it's an alias. But I'm not going to talk about this here yet. I will talk about the easy one first. Parameter I is passed by value, and I use the expression 0 to specify parameter I, and therefore parameter I as a by value parameter is getting an initial value of 0. That part is no mystery. We talked about this already. So the big question is really here. Okay, the big question is, how are we passing an entire array by reference to a subroutine? Okay, well, the way we're doing this in this class is simply to say A is also known as, in this case, column D to column F. In other words, you use one single column as a reference to multiple columns. Okay. Are there any questions about this one? That's the only tricky part. Okay, the way we utilize array A inside sum is going to be not that tricky. So if there are any questions, I think it's going to be here. Instead of having a call number of a single book, now we have a range of call numbers to refer to multiple books that are contiguous to each other. The actual way C++ does this is a little bit different, but in this class, we'll just go ahead and use this method. Are there any questions at this point? Yep, go ahead.
So, would a range of locations be able to be in one memory location since we're putting in one column?
The trick is the array B, is actually not a single thing, and it's not really just 3 columns either. It actually has the 3 columns, but it also contains a size or number of elements in it that is quote-unquote hidden, that we usually do not see. So when we have a reference, we're actually referring to the object itself that contains that information. But in this class, we'll just kind of simplify and say that, okay, here's an alias, but it's not an alias of a single column, it's an alias of multiple columns in this case.
Okay.
Yeah, so it's definitely a simplification of concepts in this case. Yep.
How do we know that A is an array?
That's a good question. Formally, what we usually do is we put, something like this here, so that we know that A is an array. But in most scripting languages, you can actually do it just the way that I do it here, because by context, it is used as an array. And also, by the way I pass parameters to sum, I'm using an array to pass to the subroutine. So that's why, even with a scripting language like PHP and Perl, particularly PHP, because Perl has special symbols to refer to arrays. But with PHP, it does, by the time you execute the code, it has to be an array. Otherwise, it will give you a runtime error. Okay, those are all good questions. In this class, we have to simplify a few things, to kind of, so that it doesn't become too difficult to deal with. Okay. Are there any further questions? Yep.
Yeah, on the main, the local variable is named B. On the invoke, it says sum A. So is A just means the array, or
okay, that was my typo. Sorry.
Oh, okay.
Okay. So maybe that was the reason why you guys are asking the question. Okay. Yep, that was my mistake. Yep. I have to use B to specify the argument. Yep. Okay. Any other questions? No other questions? All right. You can still use the Stargate analogy to understand this. We still have one single Stargate, except the other side of the Stargate is no longer a single coffee mug. It is now a box of coffee mugs. Okay, so it still works in that sense, because it's still a portal to somewhere else, except what you're reaching out is no longer a single coffee mug. Instead, it is a box, and inside the box we have 3 coffee mugs now. Okay, are there any other questions about this line when we execute line 13? Questions? Okay. So after line 13 is set up columns G, H, and I, it is time to get into the subroutine, and this is a good time to split the screen. Like so. Well, maybe actually I need a little bit more because I need comments to be available. And this return line number does not need to be there, so this would be the way to split it. So after this, we continue execution in the subroutine starting on line 4. And line 4 wants to find out, is I less than bar A bar? Okay. So let's take a look at this really kind of simple expression, but we will try to figure out how it is done. I is easy because I is a pass by value parameter. It has a value of 0. So the left-hand side of the less than symbol is just 0. Bar A bar is a little bit more difficult because when we look up A, it says, oh, okay, A is also known as column D to column F. So now you have to look up columns D to column F and say, oh, okay, column D to column F is actually an array, and it has 3 elements. So bar A bar is now evaluating to a value of 3. Is that okay? It's kind of like, you open up a portal, okay, in Stargate, and then I'm just asking you, what is the number of items in the box, on the other side of the portal? You just take a look and go, okay, we got 3 items. That's basically what it is. So now we have 0 is less than 3 is true, right? We continue execution on line 5. Line 5 is recursive. So we want to eventually execute the return statement. But we cannot do that until we have taken care of the addition. And we cannot do the addition because there's an invocation of sum itself. So this is why line 5 is recursive. We have to perform another subroutine call at this point. Okay, so we're going to call it again, which means we need another return info. We need A, and we also need I. Let's take care of the easy one first. I is easy because the current I is 0. 0 plus 1 is 1, and that's why the new parameter I is going to start with a value of 1. So that's taken care of. The second one is, well, okay, I'm just thinking about which column I should take care of next. Let's take care of column K here. Okay. When you look at line 5, I am using my own parameter A, which is passed to me by reference. and I'm passing it by reference again to the next invocation of sum. Does anyone remember when we have a parameter that is already passed by reference to a subroutine, and I want to pass it by reference again to another subroutine? Do we pass just the reference along, or do we pass a reference to a reference? That's the question. Does anyone remember?
Reference alone.
Just the reference. Yep, that's exactly what it is. Okay, I'm not sure. Did I use the proofreader example in this class? I did. Okay, so it's the same thing. Okay, I'm the proofreader subroutine, and I want to pass along the task to somebody else to do only the spell checking, right? The spell checker does not need to find my little slip of paper, because I can just say, make a photocopy of the call number and then use the call number to find a book. So that's why I'm just going to make a copy of the reference. So that's why K is basically just an alias of exactly the same columns, D to F. In this class, we do not have any cases where we will have a reference to another reference. There's no AKA of a column, and you look up that column, it is also an alias of something else. So we don't have an alias of an alias in this class. In actual C++ programming, you may encounter those cases. You may have a reference, quote unquote reference to a reference. It is called a pointer. So when you have a pointer to a pointer, then you have a reference to a reference. But in this class, we avoid that concept altogether, and we just say that, okay, every time we pass by reference, we just make a copy of the reference itself. How about return info? How do I know what else I have to do on line 5 when the second invocation of sum is done? Well, if you look at line 5, the only thing I would have taken care of when I return from the second invocation of sum is only the right-hand side of the addition. Everything else on that line still needs to be done. So that's why in the return info here, I have to say, go back to line 5 when the second invocation of sum is done. And when we get back, we still eventually want to do the return. But we only want to do the return after we figure out the sum of a bracket I and the return value of the second invocation of sum. Are there any questions about how these columns are set up for the second invocation of sum? The first invocation was done already. This is the second invocation of sum. No questions? Okay. Going forward is not really that much of a problem. It's coming, when we have to start to return, then we have a problem. Okay, so now we continue execution on line 4, because every time you invoke a subroutine, you start from the beginning of the entire subroutine, even when it is recursive. So now we go to line 4 again, and we evaluate I is less than bar A bar. I now has a value of 1. Bar A bar is still, A is still referring to column D to column F, which is an array of 3 elements. So bar A bar is 3. 1 is less than 3 is still true. We go to line 5. And this time I'm going to shortcut a little bit by copying and pasting, because the only thing that is changed is parameter I. It goes from 1 to 2. So with each recursive call, we are incrementing the value of I by 1. So this time it becomes 2. And then we continue execution on line 4 again. This time I is 2. 2 is less than 3 is true. We go to line 5 again. And then we do pretty much the same thing again, but for the last time, because this time I would become 3. When we continue execution on line 4, then we have I is less than bar A bar is false, because both sides of the comparison are 3. 3 is less than 3 is false. Are we doing okay so far at this point? Okay. Now what do we do? The condition of the conditional statement is false. We go straight to line 7, right? Okay. Some of you may realize that we have a problem. But the problem doesn't show up at this point. Okay? There's no problem. We will do line 7 exactly the way that we usually do it. What do we do on line 7, which is the end of a subroutine? In this case, that returns a value. We copy and paste the return info cell into the line number column to make a note of what we have to do after the return of the subroutine. Okay, so column P is the rightmost return info cell. We just copy and paste it over here so that we make a note of what we need to do next. And then we have no use of these 3 columns anymore, and we just indicate that these columns are no longer in use. And then we continue execution on line 5. Now we have a problem, don't we? Because if you look at line 5 here, this is what we want to execute. We don't really have a subroutine to invoke anymore, but we now have a question mark in place of the invocation of a subroutine. What do you think in the C program, if you have a program that looks like this, what do you think the C program is going to do when it tries to execute line 5 exactly the way it is specified here? Error? It's an erroneous operation, but it doesn't actually give you an error, which is the problem. Yep.
Confuses the values. Borrows the value from.
It will just add the actual value of a bracket I, which is a bracket 2 in this case, to an unknown value. Okay? In other words, the value of the question mark, there is a value. By the time you actually run the program, it will have a value, but you don't know what it is ahead of time. So the sum of a known value and an unknown value is unknown. It remains unknown. So that's why if you follow that track of thought, by the time we go all the way back to line 13, it's going to print a number. It's not going to be erroneous. It's not going to crash the program. It will give you a number. It's just that that number is not the summation of 5, 3, and 10. It is the summation of some unknown value and 18. Okay? So this is the problem. What is the source of this problem? In other words, what is causing this to happen? I'm missing something, but what am I missing that causes the program to print a random number on the screen? What do we normally do before we get to the end of a subroutine that returns a value that is missing here?
It's not returning sum.
It's not. It didn't have a chance to change the question mark to an actual value, did it? In other words, we did not execute a return statement before we get to the end of the subroutine. That's the problem. Okay. So how do we fix it? Well, this is a conditional statement. If you look at line 4 to line 6, it is a conditional statement. We specify when I is less than bar A bar, which means I is a valid index into array A, we'll go ahead and make use of that. Okay? But we didn't specify an else case, did we? In other words, we did not specify what if I is greater than or equal to bar A bar? What am I supposed to return? We did not specify anything. So that's why we have to go ahead and specify that. And we'll go ahead and insert 2 more lines here. And the first line is just else to indicate, okay, we now need to specify an alternative branch. Okay, I just undented the wrong line. That's okay. And this one, I'm just going to return a 0. In other words, you're telling me to do a summation of a part of an array that does not exist. So the summation of a part of an array that does not exist has to be 0 because it is non-existent. Are we doing okay so far? Okay. And we need a line number. I don't want to mess up the rest of the line numbers, so I'm going to name this line 5.5. Hey, it just needs to be a number somewhere between 5 and 6. So 5.5 here works just fine. The else does not need a line number because we never track the else line. So that's why else does not need a line number in this case. If you want, you can put in like 5.2, 5.3, because it will never be referred to in the traces itself anyway. All right, are we doing okay so far? Okay. So now what we'll do is we'll go back to the trace and say, okay, we need to backtrack. In other words, row 21 and row 22 needs to be deleted because we're going to redo all that stuff. Because now that the condition of line 4 is false, we want to continue execution on line 5.5. We actually have a line now. Okay. Line 5.5, let me just kind of change this a little bit. Okay, line 5.5 is to return 0. What do we do when we execute return 0? What does it mean? We change the question mark to the value that we are returning. In this case, it's just returning a value of 0. So we locate the rightmost return info cell, which is this one here, copy and paste it, change the question mark to the value that we are returning, which is 0, and we are done. Okay? We don't evaluate a bracket I at this point. We don't do the summation at this point. We just change the question mark to the value that we want to return. After line 5.5, we now can continue on to line 7. Line 7 has two things to do. One is to look up the rightmost return info cell, which is in column P, which is this one here. We copy and paste it. The second thing it has to do is to remove the 3 columns, deallocate the 3 columns that we allocated earlier. Okay, and let me just make this column a little bit wider so that we can actually see the entire thing that we have to do. Okay, so now we are now continuing execution on line 5, and it looks like this. Now this is going to look a little bit confusing because columns P, Q, and R are now deallocated. The 3 columns that I should pay attention to would be columns M, N, and O. But when you look at columns N, and O, hey, that looks kind of somewhat familiar. Okay, let's look at line 5 here and say, can we perform the addition at this point? In other words, if you look at the highlighted part of the screen, can we perform that addition at this point? Yeah, we can. I mean, the right-hand side is just the constant 0, so we can deal with that. The left-hand side is A bracket I. A is also known as column D to column F, which we already know is an array of 3 integers. I has a value of 2, so we are referring to the last item in the array, which has a value of 10. So this entire thing, the entire expression, is A bracket I plus 0 evaluates to a single value of 10. So we are just returning 10. Can someone tell me again what I need to do when I execute a return statement that returns a value of 10? We look up the rightmost return info cell, right? In this case, it's column M because the other one is now deallocated. We copy and paste that and then change the question mark to the value that we are returning. Now, this is going to look confusing, but it is not, okay? It's going to look confusing because this is what we are doing. We change the question mark to a 10. The reason why it looks confusing, it is because the return info cell that we are modifying has a statement that looks very similar to the one that we are actually executing. That's why it looks confusing. So that's why you have to kind of make sure that you understand what column B actually stands for. Column B, which is our line number column, is telling us where we are at this point and what we are doing at this point. Okay? In other words, that's your GPS. Okay? It tells you where you are right now at this point. What is the purpose of column M? It's a return info cell, right? It's a return info which is related to a return line number. Those are different, slightly different mechanisms, but they serve the same purpose. What is the purpose of column M in the context of a subroutine?
To know where to go back to after we finish executing.
Exactly. Okay, when we finish an invocation of a subroutine, where are we supposed to go back to? Okay, that's the purpose of column M. So in other words, column M is a crumb, is a crumb of bread that we left behind. Okay? Column B is GPS. That's your current location. What we are doing is we're doing something to that little piece of crumb that we left behind. I just put peanut butter on it. Okay, that's it. Okay, I'm not eating it. I'm not doing anything else with it. I'm just changing the question mark to a known value. That's all that I'm doing with it. Are there any questions about the differentiation between column B and column M? Because right now, at this point, which is row 23 of the trace, it certainly looks confusing unless you can differentiate the purposes of column B and column M, because they serve entirely different purposes. One is telling me what I'm doing, column B. One is telling me what else I should be doing when the invocation of the subroutine is done. Is that okay? Okay. So I'm kind of assuming this is okay. If it's not okay, you have to kind of let me know. Okay, we are not. I'm not getting it. We have to kind of backtrack and figure out something else. Okay. All right. So assuming this is okay, this is what we're executing. Going from here to here is the result of executing this statement. Well, now that that statement has executed, I can continue. After line 5, we go to line 7. And line 7 is going to do exactly the same thing as last time when we executed line 7. We look up the rightmost return info cell, which is this one here. We copy and paste it, basically to make a note of what do we do after this invocation of the subroutine sum. This is a reminder of what else I have to do on line 5. After that, I have no use of these 3 columns anymore. We just go ahead and deallocate all 3 columns, and then we can continue execution on line 5. But this is the line 5 that I'm executing. Columns M, N, and O are now deallocated, which means my current context is established by columns J, K, and L. I'm executing this statement, which makes use of this cell, the return info cell, and change the question mark to a particular value. The question is, what am I changing that question mark to? Well, I'm changing the question mark to a bracket I plus 10. Because return a bracket I plus 10 is what I'm executing at this point. 10 is fine, okay? 10 is all done. What is a bracket I at this point? What is I? What is the value of I at this point? It's barely visible. It's 1, right? And A is a reference to column D to column F, which is the array B. When you look up B bracket 1, it has a value of 3. So that means at this point, this is going to B bracket 1, which has a value of 3. And this is just 10. 3 plus 10 is 13. In other words, we are now executing return 13. And the effect of executing return 13 is to locate the rightmost return info cell, copy and paste it, and then change the question mark, which is the placeholder for a return value, to the actual value that we are returning, which is 13 in this case. Are we still doing okay so far? Okay. And once we execute line 5, we can now continue execution in the subroutine onto line 7, which is going to be pretty much the same thing. Look up the rightmost return info cell, copy and paste it, okay, make a note where we are supposed to go back to, and then deallocate the 3 columns that we allocated for this invocation, and then continue execution, using the line number column. And this is now my context. My context is now established by columns G, H, and I. I'm executing this particular statement. 13 is all done, okay, just a single number. We just have to find out what is a bracket I at this point. I has a value of 0. A bracket 0 is referring to B bracket 0 because A is a reference to array B. and it has a value of 5. So this portion, a bracket I, evaluates to a single value of 5. We're adding that to 13, which makes 18. We are now executing return 18. When we execute return 18, we are going to do exactly the same thing as the previous 3 times, which is to locate the rightmost return info cell, which is now column G, copy and paste it, change the question mark to the value that we are actually returning. In this case, is 18, and we are done. Okay. And after this, we continue execution on line 7, which means we are making a note of what else we have to do after we return from this invocation of the subroutine. We are supposed to go back to line 13 and finish the print statement, but we're not going to do it now. We just make a note. And then we have no use of these 3 columns anymore. We deallocate these 3 columns. And now we continue execution on line 13. Line 13 is now fully resolved. I know exactly what value I'm supposed to print. So I'm just going to make a note here and say, okay, print 18 to the screen, to a window, or to a printer. I don't really care what is the output device. And I'm done with line 13 now. Then we move on to line 14. Line 14 is the end of the main subroutine. So we have to locate the return line number. In this case, it is telling me to continue execution at post. So we make a note that we are supposed to go back to post. And then after that, we have no use of these 4 columns anymore. So we'll go ahead and copy and paste it, strike them through, and then we say we're all done. We're all done with the main subroutine. We continue execution at post, which means we're finished. It's all done. All right. I'm hoping that you guys can see the similarity between this algorithm and the one that you need to trace as your homework assignment. You doing okay? Okay, I can see that there are a few, I can see from the looks that you may not be 100% sure, how to deal with this. So what I'll do next is we'll go back to the simplest kind of return statements. Non-recursive, no conditions, none of that, stuff. But this time it's going to look like this, okay? So we'll have define sub 1, okay? It returns a single value of 1. And then we'll define sub 2, which does not return a value of 2. It returns 1 plus the invocation or the return value of invoking 1. And just to make it more fun, we'll do define sub 3, and you know what it's going to do, right? Return 1 plus invoke 2, just like that. And all we're going to do is to say print invoke 3. We already know the actual behavior, what it's going to output, but we want to know how it is traced. Okay. I hope this particular pseudocode is significantly less complicated than the previous one, but yet it has the same kind of stuff in it, doesn't it? In other words, we have the same characteristic of having a invoke on the very same line as a return, except this one is not recursive. Okay, none of these subroutine is calling itself, but it has exactly the same kind of behavior. So I'm going to trace this just so that we are clear on the concept of how to deal with a return statement that contains an invoke on it, because I think that can be a source of confusion. So we'll go ahead and trace this one. We don't even need comments in the, well, we do because we have one print statement, so we'll just do the allocation, but there's nothing to do until the very end. Okay, line number is start with precondition. There's nothing to say. There are no variables nor parameters whatsoever. This program has no local variables, no pass by value parameter, and no pass by reference parameter, no global variables either. It's really just demonstrating the concept of returning values. We start execution on the first line that is outside of the definition of a subroutine. In this case, it's line 10. And line 10 has a return info now, right? Why do you think when we execute line 10, we have to allocate a column, but instead of return line number, it is now return info? Why do we need a return info here?
Because we're still unclear on what we're printing.
Exactly. We have to go back to line 10 to finish up the operation. Okay, so that's why we need to allocate a return info cell instead of return line number cell here. So we have to go back to line 10 and we say, well, we know that we're supposed to print something, but by the time we're done with this invocation, we should know what we're supposed to print. So the question mark should be filled when we are back to line 10. There are no parameters to set up, so we don't need column D, E, or F. And then we continue execution in the subroutine that we are invoking. In this case, because we're invoking 3, we go to subroutine 3, which only has one line to do something useful, which is line 8. All right, and so now we execute line 8, or try to execute line 8. Line 8 actually has 1, 2, 3 things to do. The first thing it has to do is to invoke 2. The second thing it has to do is to add 1 to the return value of 2. And then the third thing it has to do is to actually do the return. I cannot do the last 2 operations until I know what invoke 2 is returning. So that's the first thing I need to do, is to invoke 2. Once again, we need to allocate a return info cell because we're going back onto line 8 to finish up some operations on line 8. So we have to say, okay, when we are done with invoke 2, we have to continue execution on line 8. What is left to do on line 8 is the return part of it, and also the addition part of it. The invocation itself is replaced by a single question mark as a placeholder, like that. Once we set up return info, there are no additional columns to set up because 2 as a subroutine does not have local variables nor parameters. So now we continue execution on line 5, which is the first line in the subroutine 2. And that is also, has the same pattern. So once again, we need return info cell because we need to go back to line 5. When we are done with invoking 1, we have to go back to line 5 so that we can finish up the addition and also to finish up the return part of the statement. Since we're invoking 1, we continue execution in the subroutine 1 on line 2. Line 2 is return 1, which is just returning a single value 1, which means we look up the rightmost return info cell, copy and paste it, and specify, A, 1 is supposed to return a value of 1. I don't care what line 5 is going to do with 1. I'm just telling you, change the question mark to a 1. The rest we'll do later. Okay? After line 2, we get to line 3. Line 3 is the end of subroutine 1, which means 2 things to do. One is to look up the rightmost return info cell, make a note, and say, this is what we need to do next. Okay? But we're not doing it just yet. And then the second thing to do is to deallocate the column for the invocation of 1 in this case, so that this column can be reused if we need to use another column later on. Then we will continue execution based on the note that we left behind earlier. So we are now continuing execution on line 5. The line 5 is now just return 1 plus 1. We can do 1 plus 1, it is 2. So this statement becomes just return 2, returning a value of 2. We are now executing the statement return a value of 2, which means we look up the rightmost return info cell, copy and paste it, change the question mark, which is a placeholder, because now we know exactly what the value is supposed to be. We just say, okay, we don't need to use a question mark anymore because we know exactly what it is. So 1 plus 1 is the value that we're returning, and that's why we're changing the question mark to a value of 2. And that's all we need to do on line 5. Then we move on to line 6, the end of the subroutine. 2 things to do. Look up column D and say, this is where we need to go and continue execution. And then the second thing we do is to say, oh, we don't need column D anymore, and so it is now deallocated. And then we continue execution on line 8. line 8 looks like this at this point because the invocation of subroutine 2 is now done, and it is resolving to a single value of actually the 2, the numerical value. So now we can say, oh, okay, we know how to add 1 to 2. It is 3. So we are actually executing return 3 in this case. To return 3 is to copy and paste the active, rightmost active return info cell, change the question mark, which is our placeholder, to the value that we are returning, and that's it. That's all we need to do on line 8. After line 8, we continue on to line 9, which means we have to make a note of what we need to do next, and then we have no use of everything that we allocated for this invocation. And then we continue execution on line 10. Line 10 is just printing a value of 3 at this point. Sure, we can do that. After line 10, we get to post, and that ends the trace of this particular pseudocode. So I'm hoping this is helping a little bit to make it less confusing, because we are no longer, the return info cell doesn't have the same line number as line number anymore. So that's why it is less confusing, but it's the same concept, same principle. We haven't changed a single thing from day one, from the first time we talk about the return statement. Are there any questions about this one? No, yep, go ahead.
So before, when the return info and the line number were the same, is that because it was recursive?
Yes, it is. That's exactly the reason, because it is recursive. Because if it's not recursive like this one, then the return info cell would contain a line number that is different from yours, because it's not coming from the same subroutine. Yep. And that's the reason why the other one looks confusing, because we are copying and pasting a return info cell that looks almost identical to the statement that you're actually executing. So the confusion is, which one am I executing and what am I doing with the other one? Okay, are there any questions? At the risk of boring myself and the entire class, let me just ask this question. What do we do when we execute a return statement? Let's say it's return 5. Okay, what do we do with return 5 when we execute it?
You replace the question mark. And
Well, first of all, we have to find out which return info cell we are supposed to change, right? So which one do we change? The rightmost active one. So it has a return info cell, and it should have one single question mark, right? So what do we do next?
you replace that question mark.
We copy and paste it first, and then we replace the question mark with the value that we are actually returning. What if that return info cell that looks identical to the statement that I'm executing? We don't care. We don't care. We have a tunnel vision of only the question mark. Okay? If it looks exactly the same as the statement that we're executing, who cares? I don't care. We just change the question mark to the value that I'm returning. I'm done. I don't look at it anymore. Okay? That is the number one reason why people get slightly confused when we deal with returning a return statement that also includes an invoke inside it. Okay? So are there any questions about this particular sample program? Because I'm hoping that this one will help clarify some of the confusion from the previous one. Question? No, okay. If there are no questions, then we are going to move on. Okay? All right. So we are now moving on to the exam 2. I don't think I can finish all the questions from exam 2 today, so we'll go ahead and only deal with as many as I can. So we'll go back to, I'm going to borrow the exam from the other class because the first 4 questions are actually pretty much identical between the 2 classes, but they're not exactly the same. Okay, so get to you cannot get to this one because it's actually in the other class. Okay, there we go. Exam 2. And the first question is the pre and post condition one. Okay, so here is something that should look similar. I think in this class it's almost the same, but not exactly the same. Okay, so we'll start with this one. The approach is the same. The first thing you have to do is to say, well, I'm given the post condition that right after line 5, x equals 5, y equals 4, and k equals 2. That's the known condition after the entire conditional statement execute. So the first thing I want you to do is to figure out what is pre-1. In other words, can you tell me what is the condition right before line 1 executes, other than true? Other than, yeah, we started on line 1, okay? Because if you say pre-1 is true, that's pretty much all you're telling me is, yep, we somehow started on line 1. Okay, so let's go ahead and try to do this step by step. In your answer, you don't have to do this step by step. In other words, I'm not going to knock points off because you did not explain to me how you got to pre-1. But I would do this step by step, just so that I can leave notes to myself, to explain my own reasoning. Okay. So we know that post 5 is the following: x equals 5, y equals 4, and k equals 2. Okay, that's all given to me. All right. Post 5 is after the two branches merge. So the first thing I want to do is to go back up one step and say, well, that could be the result of line 2. That can also be the result of line 4. Is that making any sense? Okay, so I'm just looking for a dryboard marker. I don't have one.
Under your papers.
Hmm?
In your box.
In my box. Oh. Okay, I hid one. Okay, so a conditional statement looks like this. Okay, I'm just trying to simplify the drawing of one at this point. This is post 5. I know that after the two branches merge, that x has a value of 5, y has a value of 4, and k has a value of 2. But that could be the result of this branch, can also be the result of this branch here. I don't know, whether one is possible but the other one is not at this point. So all I can say is, hey, it is possible that post 4 is post 5, which means it is x equals 5, y equals 4, and k equals 2. Let's just focus on this one, okay? So after line 4 executes, somehow I got to this result here. If this is the post condition of line 4, is there a way to tell me what is the precondition of line 4? In other words, after I subtract the value of k from the value of x, x somehow ended up with a value of 5. Can I reverse that operation and say, if that is the case, x must have this value before line 4? Is there a way to reverse it? Okay, so how do I reverse it? X has a value of, has to be 7, right? Because after subtracting 2 from x, it becomes 5. So before I subtract 2 from it, it should be 7.
Any best roll sheet?
I don't have a row sheet anymore. We are past the last day to drop from the class. So I cannot drop anyone in this class anymore, and neither can you. So we are all locked in now. And don't get used to having the last day to drop like 3 or 4 weeks before the end of the entire semester. When you move on to UCs or CSUs, I think it's usually within 2 or 3 weeks, something like that. Yeah. So don't get used to it because it's not going to be the same, in a 4-year university. Yep.
In our exam was k equals 2 or 3.
Say it again.
In our exam was k equals 2 or 3.
It's probably 3. Yeah. So this is borrowed from the morning class. Okay, but it's the same kind of question. So you just have to apply your reasoning, just tweak it a little bit. But it's the same kind of reasoning. Okay, but there's one more thing that I can say about pre-for. Because line 4 is also the first line of the else branch, okay? And that has a significance because pre-for has to match this condition too, or I should say the negation of that condition. Because if x is actually less than y, I would not have ended up on line 4. So that means it has to be not the case that x is less than y. So I have to throw that in, okay? This is something that I have to throw in because of the structure of a conditional statement. But is that going to cause any problems in this particular case? In some cases, it can cause problems. It can cause a contradiction. But in this case, is it causing any contradiction? No? Okay. So if it is not causing any contradiction, and since this is not a logic class, I will take this particular answer as the answer. Okay, if you want to show the steps and you say, okay, I can only work my steps up to this point, that's good. Okay, as a precondition of line 4, not a problem. So now we have post 2. Post 2 can use the same reasoning and say that, well, since we know after we merge, post 5 has that condition, but we could have come from the end of line 2. So that's why post 2 can be the same as post 5. Which is, well, the same thing. X equals 5, y equals 4, and k equals 2. Can I reverse this back to pre-2? If you look at the nature of line 2, it looks kind of the same as line 4. It's reversible. So this means after I add 2 to x, x became 5. So what should be the value of x before I add 2 to it? 3. Okay, so that's why x equals 3, and y equals 4, and k equals 2. Okay, but there's one more thing I also know for sure, because line 2 is also the first line of the then branch. That means the precondition of line 2 also needs to meet the condition of the conditional statement, which is x is less than y. Is that causing any type of conflict here? Nope, it's not causing any conflict, so I can keep the entire thing. Okay, so now we have pre-2, which is the precondition of the then branch. We have pre-4, which is the precondition of the entire else branch. Can I figure out what is pre-1? It's just the disjunction of the two. Because what I have here is pre-2 is here, pre-4 is here, and I want to figure out what can possibly be here. Well, since both branches merge back into line 1, it can be one or the other. Okay? So now the whole thing looks kind of nasty because now we have this or that. Because one looks like this. Okay, that's actually pre-4. I mean, yeah, this is pre-2. So we are looking at something that looks like this. If someone tells me this is the precondition of the whole thing, I would just say, okay, that's fine. I would take it as an answer. Not a problem. However, there are ways to simplify this. Okay, so I want to show you, how to simplify this. How many people are here for the computer science transfer degree? Okay, it's actually the minority. Interesting. Mr. Fox, Professor Fox, is retiring. So that means, he's not going to teach CISP 440 by the time you get to CISP 440. Guess who's teaching it? You're like, no! So I'm teaching CISP 440, and CISP 440 is the math class. Okay, that really is the math class. I will teach you, all the formal proof techniques, proof by induction, proof by contradiction, and all the other fun stuff. Well, I'm not going to tell you whether I'm looking forward to it or not. Okay, so we'll take a look at this one here and say, can we simplify this? In other words, let's knock off the items that is extra, that doesn't really add information to it. Okay, let's see which one we can just say, that's not new information. Let's start with something obvious. Can I just get rid of k equals 2? Is the rest of this conjunction implying that k equals 2? No. Just knowing that x equals 3, y equals 4, and x is less than y doesn't tell me a single thing about k. So k equals 2 is essential. There's no other way to say that k equals 2 in the conjunction. Okay. What about this one? Can I get rid of y equals 4? Now, if I get rid of y equals 4, the rest would still be okay. Okay, x equals 3 obviously is not affected. K equals 2 is not affected. X is less than y is also not affected, but I lost some information. Okay, because I used to know that y is exactly 4, but if I get rid of y equals 4, then the only thing I know is y is greater than x, which means it can be 4, can be 5, can be 6, can be all the other numbers that are greater than 3. Okay, so I really don't want to get rid of y equals 4. And the same reason applies to x equals 3. If I get rid of x equals 3, then all I ended up with is x can be 3, can be 2, can be 1, can be 0, can be -1, and so on. So I don't want to get rid of it either. What about this one here? Can I get rid of x is less than y in this conjunction, but without losing any information? Yeah. Why do you think that is the case? What implies x is less than y in this case? Yep, x is 3, y is 4 implies x is less than y. So if you have a conjunction and some parts of the conjunction implies another part, the part that is implied is redundant. It doesn't need to be there. So that's why the first thing I can do with this one here is to simplify and say, hey, this part doesn't do me any extra. It doesn't add any information to it, so I can just get rid of it. Okay. So we'll go ahead and look at the other part of the disjunction and say, well, out of this entire thing, which part is extra? Which part can be implied by the other parts of the conjunction? X is not less than y, right? Because knowing that x is exactly 7 and y is exactly 4, that implies x is not less than y. So x is not less than y is extra. It doesn't need to be here. It doesn't add it doesn't add any information to the conjunction. So we'll copy and paste it and just say, well, this part is not of any use. So we are now simplifying the two statements or the two conjunctions a little bit. At this point, I can still make one more transformation to make it quote unquote easier to read. Because you can identify that both conjunctions contain this particular component. So just like with factoring with numbers, you can do a factoring with Boolean expressions. So you can now say, this part is obviously extra. You don't have to do this. But I do want to show you what we can do with this. So the entire expression is simplified to saying that, okay, we know y has to be 4. We know k has to be 2. But you know what? X can be 3 or 7. Okay, if x is 3, it gets me to the same result. If x is 7, it gets me to the same result too. Are there any questions about how I simplified pre-1? Now, as far as your answer is concerned, if this is your question and you give me something that is, well, eventually means exactly the same thing, it's going to be okay. Okay, I'm not going to look for the simplest way to express it. It just has to be meaning exactly the same thing. Okay. Are we doing okay so far at this point? But that's not the end of this question, is it? Because we have to go forward again. Okay. So as a part of the question, it says then use the pre-1 that you figure out and derive post-5. In other words, we want to go forward again using the substitution rule, forget rule, and all the other stuff. Which part do you think is more complicated? I'm asking it as a question, not as a suggestion.
The first step.
The first step. So reversing is actually the harder step. Going forward, okay. Going forward is more mechanical because it's all template based. Going backwards is not mechanical because it's not required in the class. So it all depends on how you look at the problem and also look at whether you can follow the steps that I use in the class. Okay, so let's go forward again using pre-1 like this one, and then we'll just go ahead and move forward at this point. Now, knowing what is pre-1, the first thing we want to do is to figure out what is pre-2 and what is pre-4. Pre-2 is pre-1 and the condition of the conditional statement. This has to do with the structure of a conditional statement. It's because between line 1 and line 2, there's nothing that can change the value of the variables in this case. So that's why pre-1 still has to be true when I get to line 2. But if that is where I'm going, it also implies that x is less than y has to be true, because otherwise I won't be going to the then branch of the algorithm. So after that, it's really just a matter of copying and pasting. So we'll just take the simplified version, and then we say and x is less than y. If you just give me this, it's fine. Okay, it is correct, even though certain improvements can be done here. Because if you look at this whole thing, because we have x is less than y here, and it is using a conjunction to connect to the rest of the expression, and yet on the other side we have, oh, maybe x can be 7, but we know y has to be 4. So that means if you want to do a simplification, you can get rid of this at this point. Okay, you can safely get rid of this part as well as this part here at this point, because this one can be implied and this one is conflicting with x is less than y. Okay, but if you don't do this, if you do not do the simplification, that's fine. We'll just leave it the way it is. And we can do about the same thing with pre-4. So pre-4 is the same as pre-1 and the negation of the condition of the conditional statement. So once again, we'll go ahead and just do a copy and paste here. Just like that. Okay. How do we go from pre-2 to post-2? If you want to go from pre-2 to post-2, it has nothing whatsoever to do with the rest of the algorithm. You can get pre-2 wrong entirely, okay? But if you say, oh, pre-2 is the right-hand side of line 2 is reversible, then you get points already, even though your precondition is entirely off. Okay? So if you just tell me that the right-hand side of line 2 is reversible, f of x is x plus k, the inverse function of that is x minus k, that's worth points already. Because that is a reason to use a particular operation. Which operation should we use? Use the substitution operation. Okay? And then you have to say, how do we relate the precondition of line 2 to the post condition of line 2? This is a template. Okay? I have used this template many times in this class. The post condition of this line is a substitution of the precondition of the same line. We locate the variable that is being changed on that line, which is x, and we substitute every occurrence of x with f prime, the inverse function, applied to x. And then you can just go ahead and expand this. I know this is going to be a little bit tedious because we have a fairly long precondition here. So we take every single x and we replace it with x minus k in this case. And step 3 is really just doing it, right? X minus k equals 3. Or x minus k equals 7. Close parentheses. Y equals 4. K equals 2. And x equals k is less than y. If you just go ahead and mechanically replace all occurrences of x with x minus k, I'll give you the full points for that particular part of the question. Even if your precondition is wrong, if you do this step here, I'll give you points for this particular step. And that's why you have to show the steps, because the steps are the part that actually worth points. It's not the final answer. It is the steps that are important. Okay. Any questions about this part? Now, knowing what is post 2, I'm going to kind of shortcut a little bit here. Post 4 is going to be almost exactly the same thing, except instead of x minus k, it is x plus k. Instead of x plus k is less than y, it is not the case that x plus k is less than y. So I'm just going to shortcut the whole thing because I want to get out on time. Oops, wrong place. Paste it here. So instead of all the minus, we have the plus. And then put a negation here. Okay, so that's basically the mechanical result of post-war. And if you run out of time, you cannot do all the copy and pasting on a piece of paper. And this is all you can say is to say post 2, post 5 is post 2 or post 4. I'm going to give you partial credit for this part already, because this is important. Okay, post 5 is post 2 or post 4 is due to the structure of a conditional statement. If you just say this part here, it tells me that you understand what the post condition of a conditional statement really means, okay? Because we can come from either branch. Now, if you have time to actually do the copying and pasting, that's even better. Okay. So in this case, we have this whole thing to go here, and then we have the other thing to go to the other part, which is here. Okay, so now we have the whole thing done. Okay, this is, well, not. Okay, this is not worth the entire point value for this particular question because I kind of shortcutted a little bit here. But that's what I'm looking for. Okay, I'm looking for the derivation going forward. But what if? But this doesn't seem right. Okay, this post 5 that I'm deriving from the pre-1 that I figure out is a huge mess like this. Not quite like what is given to me. What is the problem here? Is there a problem, first of all? Okay, let me pose that question in a slightly different way. Okay, when this whole thing started, I started off with something relatively simple. Okay, that's my post 5. Okay, maybe the program crashed at that point. Maybe this is not what it's supposed to do. But at any rate, I observed that on line 5, I have this condition. Okay, I went back and figure out, hey, you know what? From that, I can infer that on line 1, before line 1 executes, this is true. Okay, x can be 3 or 7, y has to be 4, and k has to be 2. And then I use all the techniques that I learned in this class to derive post 5 again, due to the structure of the conditional statement. And I ended up with something that is really messy, big, huge, and messy. Is there a problem?
A value is 2b, is that subroutine?
Yep. This is really just a long and redundant and really nasty version of the simplified one. In other words, if you apply logic and substitute k with 2 throughout the code, you will end up with exactly the same expression. Now, you don't have to do that step. Okay? If you just say, well, mechanically speaking, I end up with this post condition, leave it the way it is. That's worth 100% of the point value for that part already. I don't need you to go all the way back to this form. I just need to understand. I just need to know that you know how to derive it. Okay. So that means there are opportunities to get partial credit. Even if you get pre-1 entirely wrong, you can still get partial credit. Is that making any sense? because it is the steps that are important. It's not the final result that is important. Okay. Well, we are running out of time today, so we'll continue this on Thursday. And we only have Thursday and next Tuesday for lectures, because do we have next Thursday too? I think we have next Thursday as our last lecture, and then it will be a week of final exams.